Hi everyone. Let's take a look at number 7 on page 386. Determine k given two vectors and the angle between them. Part B. Vector A equals to 1, 1. Vector B equals to 0k. And the angle theta is 45 degrees. Step 1. Write down the definition of the dot product. Vector A dotted to vector B equals to the magnitude of vector A times the magnitude of B cosine the angle between them. Now from the given, again, let's highlight this for you. A is going to be 1, 1. B is going to be 0k. So this equals to, let's write it better for you, the magnitude of A. So again, because A is going to be 1, 1, the magnitude of A is going to be the square root of 1 square plus 1 square. And the magnitude of B is going to be 0 square plus k square square root cosine the angle between them, which is 45 degrees. Now, on the left-hand side, when you think about the dot product, that's going to be 1 times 0 plus 1 times k, which equals to, here comes the mental math, 1 square plus 1 square, that's going to be 2, underneath the square root, the root 2, times, and this is the most important part of the whole video. Are you ready? Mentally lean forward. Think about this. This is something that I want to really make sure nobody is left behind and this makes sense to you. So I'm only going to write down the square root of k squared for now, and we're going to break this down a little bit more in a moment. When you think about cosine of 45 degrees, that's exactly 1 divided by root 2. So I can cross out from the top and the bottom 2 divided by 2, or I should say root 2 divided by root 2, that's going to be 1. On the left-hand side, again, 0 plus k, that equals to k. And here comes the major concept. By definition, and again, something you did maybe back in grade 11, depending on who taught you and so on, by definition, the absolute value of k equals to the square root of k squared. And you want to be careful here because notation matters. This symbol means the absolute value. So not the magnitude. I'm talking about the absolute value. So let's use a different color again, or I shall use the same color here. Those symbols means the absolute value. So when I write down k equals to the absolute value of k, that is what you're trying to do. You're trying to solve for k here. So a couple of cases you want to think about, right? So if I draw a line in the middle and I divide this into two different columns, first of all, recognize that the absolute value of anything could be positive. Or in this case, if you look at it carefully, it could be 0, by the way. So one solution, of course, is you can say k could be 0. And we know that because if you plug it back in, we're saying that 0 equals to the absolute value of 0, and that is definitely true. The second statement is to say k could be positive. And again, this makes sense because if you think about, for example, k equals to 5. 5 equals to the absolute value of 5. And again, this is not a proof. I'm just verifying it with one specific number, right? So the general answer is going to be therefore k must be greater or equal to 0. Now, let's over-deliver. Let's make sure you understand what this really means. So I'm going to draw a graph here. And again, this is something that I'm giving you because I want to make sure you really understand this and because you're promoting or you're activating that dual mindset. So when I think about the scale, 1 and 1 in the first quadrant, from the given, I know one of the vectors is going to be A, which is 1, 1, which looks exactly like that. So again, this is going to be vector A, 1, 1. Now, vector B, by the way, is going to be 0k. 0k may look something like this or like that. But now you know that is not the case because the angle between them is 45 degrees. So when you think about OK, this could look something like that. And this is 45 degrees. Now notice how this is not the only answer. I'll say this again. This is not the only answer. So when you think about vector B, which is 0k, k could be any positive number. So someone could say, what about this vector? What about this other vector? What about this other vector? There are infinite many vectors for b, where b is 0k. Now the one I cannot draw here is the 0 vector. So again, this case, when k equals to 0, this is something that, again, because you activated dual mindset, it will make sense to you. Graphically, you're not going to draw a 0 vector because the 0 vector has no magnitude and no defined direction. However, if you go back here, again, when k equals to 0, you want to go back and verify algebraically, does this make sense? So if I plug in k to be 0, that means on the left-hand side, it's going to be 0 plus 0. On the right-hand side, this is going to be 0 times 1, which means 0 equals to 0. So again, I'm not proving this. I'm just mentally double-checking quickly that not only can k be greater than 0, but it could be equal to 0. And therefore, again, k is greater or equal to 0. I hope this makes sense.